Welcome to RhinoCFD Basics.
In this video we will illustrate the principles behind how to set up a transient case. CFD simulations can be of two types, steady state or time dependent. The former assume that the boundary conditions we want to simulate are constant. The latter, on the other hand, allow for time dependent variations to be taken into account, both in terms of the flow and the geometry. For example, a fire growing in strength over time, gusts of wind past a building, or a boat screw rotating through water. It is also possible to have steady cases, which lead to naturally unstable results, for example vortex shedding behind a cylinder, for which you need a transient simulation to fully capture the physical phenomenon you're modeling. In general, transient simulations are more computationally expensive than steady-state ones, and require greater care to set up. On the plus side, they can sometimes be easier to converge, as the time marching provides an inherent level of relaxation to the simulation. In order to switch from steady to transient, enter the main menu and click on Geometry, and then on the button that says Steady. It will change to say Transient, and an extra button to edit the time step settings will appear. In the time step settings panel, set the real time length of your simulation. Input your desired value in seconds into the box called Time at the end of the last step. To change the number of steps completed during this time frame, edit Last Step Number. This divides the total time of your simulation by the total number of steps, and thus defines the size of your time step. Choosing the size of your time step depends on the case you're modeling, and is related to the flow conditions. In general, though, the smaller the time step, the more likely the simulation is to converge. It is also possible to split the time steps into regions. This can be used to allow a smaller time step at different points in the simulation. After setting up the time step, it is necessary to define the initial conditions for the domain. To do this, go to the Initialization tab on the main menu. The default is 0 for all variables, but in many cases these will need specific values, for example if modeling the emptying of a container which is originally full of water. It is sometimes useful to run a steady simulation and restart using Transient to ensure the correct initial condition. A typical steady simulation may need hundreds to thousands of sweeps. However, transient simulations normally require only 20 to 50 per time step. In general, if you find your time steps are not converging with 50 sweeps, it is preferable to reduce the size of the time steps than to increase the number of sweeps further. This can be adjusted on the Numerics tab in the main menu by changing the total number of iterations. Transient simulations will produce results for each step. In order to view these results, they must be dumped or saved to your working directory. To do this, enter the main menu and click on Output, and then on Field Dumping. Edit step frequency to 1, and enter any letter into Start Letter for Phi. This letter is only to help distinguish between different runs when viewing files. Start by viewing the results in the usual way, by clicking on the Load Results button on the main RhinoCFD toolbar. A panel will appear asking you which result you'd like to load. Most options are self-explanatory. To select a particular time step, click on Use Intermediate Files and select which time step you'd like to see. Selecting one will give you the first time step. You can then use the toolbar menu to cycle through the time steps individually, or play a video that automatically loops through all of them.
Thanks for watching this RhinoCFD Basics video. For more information, please visit rhinocfd.com.